Hello, hello, chemistry. First thing I need to say is that if you don't have the hard copy from in class, then you need to go to Classroom and pull up worksheet 5, which is this. Okay, what I'm going to be doing in this video, I'm going to give you some notes that you should add to the top here, and we're going to be adding letters into these blanks in the margin. So just this column. None of the rest of these. Just this column of blanks. Okay? So today we're talking about the 5 types of reactions. So if you take a look at reaction A. Okay, so that's the one labeled A on the worksheet, in case you were confused. Okay? If you look at it, you'll notice that there's a plus sign there, there's an arrow, and then there's 3 formulas. Okay, the arrow is how we identify reactants and products. Reactants are what go into a reaction, products are what come out. The arrow points at the products. Now, on this worksheet, the arrows are all pointed in the same direction. On the quiz, some of them are going to be pointed in the other direction. Okay, you have to pay attention to which way your arrow is pointing so that you can tell which way the reaction is going. So keep that in mind as you move forward. Now, if you look at reaction A, you'll see that there are multiple items on one side of the reaction, but only one thing on the other side. Specifically, we have Cu here. Ignore all these things with parentheses. They don't matter. We have Cu, we have O2, and then we have CuO. Each of these is a separate formula. You can tell that by the blank, the arrow, and the plus signs that separate them. Okay, you'll never have a big gap in the middle of a formula. Okay, so we have 2 items on this side of the arrow, the reactant side, and 1 item on the product side. Okay, that 1 item on the product side is extremely important because one of our 5 reaction types is a composition reaction. In a composition reaction, we put multiple things in, but we only get one thing out. Okay, so a composition reaction is putting things together. So the key thing that you need to remember that I want you to write down up here under CP, under composition, is 1 product. A composition reaction will always have only 1 product. A decomposition reaction is the opposite of a composition reaction. So a composition reaction has 1 product. A decomposition reaction has only 1 reactant. So that's what you want to put down for decomp, is that there's only 1 reactant. Now, what I want you guys to do is pause this video and go through and identify all of these, which are composition and decomposition. Go ahead and do that real quick, and pause this while you do, because I'm going to kind of, chug ahead. And I will tell you here in a second how many there are. Did you do it? I hope so, because I'm about to tell you where they are. Not where they are, but how many there are. There are 4 composition reactions and 3 decomposition reactions. All right. Next is, on this list, next is single replacement. I'm going to skip single replacement because single replacement is a little confusing. So I'm just going to go ahead and jump down to double replacement. Now, here's the thing between single replacement, double replacement, and combustion. All 3 of those reaction types have 2 reactants and 2 products. So they all look kind of similar at first glance. But when you know what you're looking for, you'll notice that there's some definite ways to pick out which one is which. Now, the first one, the main one, for double replacement, well, for all 3 of them, so there are some compounds and some elementals. Now, you remember we talked about diatomics. Okay, diatomics are our magic 7. they can appear with a subscript 2, like O2 or N2, Cl2. Those are considered elementals. They're called diatomic atoms. So those are not a compound. They do not count because there is only one element present. There's 2 atoms, but there's only one element. In a double replacement reaction, there's actually 4 compounds. So all of the pieces are going to be compounds. So if we were to look at reaction D, we have AsCl3, which is a compound, H2S, which is also a compound, As2S3, which is a compound, and HCl, which is also a compound. So all 4 of these are compounds because all 4 of them have multiple elements present in their formula. So that one has to be a double replacement. So go ahead, shoot through those, and identify the double replacement reactions. All right? And again, pause this while you do, because I'm just going to kind of shoot ahead here in a second. All right. There are 5 double replacement reactions. I'm not going to tell you which ones they are yet, though. Next, we're going to go to combustion. And for that, I'm going to move the screen a little bit here and draw your attention to this over on the side of the board. Okay, the reactants and products for combustion reactions are very consistent. Okay, the reactant are always going to include O2, oxygen gas, and an organic. Okay, and that is something with formula CH, and it might have an O. Subscripts are irrelevant, but if it's C and H or CHO, that is an organic compound. Okay, so that's a pretty good indicator that's probably going to be a combustion reaction. But O2 is not always going to be present, or not everything that has O2 as a reactant is going to be combustion. Single replacement reactions will frequently have O2 as a reaction, as a reactant as well. So what I recommend is not looking at the reactants, but looking at the products. The products for a combustion reaction are always H2O, water, and CO2, carbon dioxide. Both of them have to be present. If only one of them is present, it doesn't count. It has to be both. So look at what's left and identify your combustion reactions, CB. Okay, by the way, if you didn't, then up here, under double replacement, you should have put 4 compounds. And under combustion, note the products are always CO2 and H2O. Identify your combustion reactions. Do not put in anything for single replacement yet. Okay, hoping you've done that because I'm about to tell you the answers. There are 6 combustion reactions throughout the entire thing. Now that means that everything left is single replacement. But there are 2 kinds of single replacement reactions. That is anion replacements and cation replacements. In an anion replacement, the anion of a compound is being replaced. In a cation replacement, the cation of the compound is being replaced. Now, this is content that in my mind is more suited for chemistry 2. And when I did cover it in class, people got really confused by it. So I'm going to give you some key things to keep in mind, and you do not have to identify them based on which kind they are, but you need to know that there are 2 kinds of single replacement reactions. You need to know that there's a cation replacement, and I would write these down if you're not. You need to know that there could be a cation replacement or an anion replacement. In a cation replacement, the cation, the first part of the element, is being swapped out for something else. Subscripts don't matter. The element changes from iron to hydrogen or something like that. Aluminum to iron is another good example. Okay, but the first part of your compound's formula is going to change. So if you take a look at C, the compound on the reactant side is H2O. On the product side, though, the compound is Fe3O4. O stayed the same. It's present on both sides. But hydrogen was exchanged for iron. So that's a cation replacement. For an anion replacement, take a look at reaction Y. is in the letter Y, the second one from the bottom. Okay. In that one, the compound starts out as Bn and then ends up as BF3. So the B stayed the same. The first thing in the formula stayed the same. But the second part changed from an N to F. So it went from nitrogen to fluorine. That's an anion replacement because the second part of it was exchanged. So go ahead and put down SR, single replacement for everything. And for single replacement, the big key is going to be that you always have 2 compounds and 2 elementals. However, most people just end up identifying everything else, or eliminating everything else, and then they identify the single replacement. So if that works for you, that works for you. One other thing I want to mention, which I did at the beginning of class but forgot to do at the beginning of this video, was to talk about the 6th reaction type. There are a couple of things you need to write down about the 6th type of reaction. These are the only things you need to know about it. Okay, you need to know that the 6th type of reaction is called a redox reaction, R-E-D-O-X, where the R and the O are capitalized. They are capitalized because redox is the shorthand way of writing an oxidation-reduction reaction. So that's O-X-I-D-A-T-I-O-N hyphen R-E-D-U-C-T-I-O-N. So oxidation reduction. Oxidation reduction reactions deal with a change in oxidation number of the reactants and the products, which we're not going to get into that much. That, again, is Chem 2. So that is it. That's all you need to know. I am going to step aside so that you can take a look at this. Some people have found this information on the board behind me helpful. So I'm going to step aside so you can get a better look at it since I've been in the way this whole video. So that is it. I will scroll back up to the top and then slowly come back down, and then the video will end. So have a wonderful night, and I will see you all in the next video. So this is where it started. Some terms, some information on the reaction types, and that's it. Have a wonderful night.